This is the Crypto Hipster Podcast. This is not a traditional interview show. These are perspective-driven conversations with founders, builders, and independent creators shaping what comes next. We go beyond headlines, beyond hype, and beyond price to explore ownership, freedom, and opportunity in the digital economy, where builders talk freedom, not price. Today, we're not talking about price or narratives. We're talking about something that's far more dangerous. What happens when the data that we trust in crypto lies? I have Victor Fay from Ormi Labs today. So, Victor, let's ask you first. When does on-chain data stop being truth and start being interpretation?
This is, first of all, very relevant question because this is right following the heel of the recent hack in layer zero with Aave, withdrawal, frozen all that. So kind of this is crazy because, for example, with on-chain data, right? First of all, one source is RPC. In fact, a lot of the data comes from RPC. What happened in the recent event was that the attacker was able to manipulate the RPC, returning the false data, while meanwhile DDoSing the other providers. So in one sense, they end up having bad data, and because of that, the hack was able to happen. This is just one of the potential, failure scenarios in the entire crypto or Web3 stack.
Let's slow that down for a second. Right? The blockchain didn't fail. The data people trusted did.
Data quality or data accuracy, just potential failure scenario, but nobody really truly considered. But I think after that hack, this actually has been at the forefront of the industry. It's a problem that people actually do not know what's the best solution to that.
So people say that crypto is transparent. Is it understandable and transparent?
It is transparent, yes, and it is understandable, yes. But when there are hundreds of billions of transactions, to be able to normalize and to actually find out what is actually true, what's actually not, that's a non-trivial, infrastructure, to get to that point. So in a way, it is transparent, but to actually verify that accurate transaction, it does take, resource. So that's the draw. That's the that's the hardest, difficult side to that. Yeah.
You mentioned Aave. From what I see and from the comments in the market, is a lot of people didn't understand what was going on. So when I say is crypto transparent and understandable, we have proof that it's not understandable, right?
I think let's put it this way. It's I think you might need something close to a PhD to really truly understand the entire stack, because it is transparent, but it's a very complicated system. All the source code is out there for obvious cases. All the failure scenario is there, which is good, right? It's much better than some centralized, couple of people making decision in the room. But just a matter of fact is because this has to be globally resilient. So therefore, there's so much complexity built in. That's why, normally people have professional teams to audit. It is transparent, it is there, but it does take a lot of, mental understanding to really grasp on what's going on. So this is just, in a way, the trade-off. Yeah, to have something public but complex, verifiable, or have something that's in the black box, you trust an authority. So this is just the trade-off I think there is.
So you're saying that in order to understand the blockchain, you need a PhD.
Maybe not a PhD, but I'd say somebody who tell you they understand exactly all the failure scenarios in DeFi. They understand every single piece of infrastructure that goes on in crypto completely. I think that's a little bit overstated because similar to the modern cloud infrastructure, right? It's fairly complex, but I think it's a sign of maturity because a complex system is mostly dealing with all those corner cases. So I'd argue, yeah, per transaction validation, whether your funds are actually safe, that is easily verifiable, and it's an open platform that people have been building towards that optimization. But you're saying, hey, we understand? Can we see into the future that the Aave or layer zero hack happened, that we could have prevented that? In a way, yes, but that's kind of one of those surface that people have not really fully thought through. And so that's the part, is like, hey, you need a security in PhD in order to truly understand this. Yeah.
Yeah, most people don't have that, and in lieu of not having that, they have to trust on-chain data.
Right.
So where does the on-chain data mislead people the most?
um so maybe let's if you don't mind, like maybe I will kind of come back to answer this question, because I think I had something I wanted to add earlier, like it's also related to this. So in a way, it's not the on-chain data misleads people. It's just at this very moment, right? When you look at on-chain data, people go to Block Explorer. People look at hexadecimal transaction. Those are machine friendly, but those are not human friendly. So this is not just individual person. That's why every institution is thinking about crypto. Every institution is buying crypto, but they're looking at Bitcoin because that's easy to understand. They're looking at stablecoin because that's easy to understand. DeFi, it's like about 5% adoption. Why? Because it's complex. Because there is a risk associated with the complexity. We're building towards there, but it's not there yet. And part of that is just the complexity of the data. Right now, when you look at on-chain data, okay, there's balance. You have to understand the details of every single smart contract in order to know to piece together how the routing works and all that. And then you would need a secondary service, to build data model on top, right? Whether that's supplying live data to an application, that's what we do, or like an analytical, type of dashboards. But that would also involve secondary human resources to piece together, a human digestible data model. So that chain is, kind of that application level of filtering, forming data model, represent to an end user. That historically has been very expensive. Yeah. So
So
it's
what
not
you're
it's not it's not like it's false. It is true. Everything is there is true. There are differences, right? Different RPC provider may be returning slightly different truth, but those can be normalized. But in order to normalize, generate the accurate data model, it does take a lot of resource to do that. Yeah.
so you're saying everything, if everything's true, why did Aave in particular? You might want to use another example if you want, but why did it fool so many people?
Um, so the it's full the protocol, right? That's because the protocol had 3 or 4 RPC source, right, that they trust, and those RPC are centralized provider. When you manipulate two and deny the rest on the application level, when they're doing that validation normalization, it just attacks surface that they did not consider. So that's more like a failure in like the system, in a way, like application level. It's not blockchain level, it's more further stream application. So this brings you to another kind of point, right? Blockchain, when it first was conceived, is very much optimized for writing. It's not really optimized for reading. People talk about, oh, how can we make sure one transaction written on there is not being double spent, is not being happened like kind of transacted the second time, say money isn't spent twice. But people really haven't thought about, hey, once a robust application or ecosystem start to form on top, how you get data reliably and verifying that data out of blockchain, that's a whole other piece of complex infrastructure where the issue happened. Yeah.
So I want to get into that. I want to get into the system risk. It says what there's one more piece of architecture, and talking about the architecture, indexing. Where does indexing sit in the stack, and why is that important, and how does that hope to lower the system risk?
Okay, so indexing is essentially the most critical piece, right? Because the applications we interact, if you're a DeFi user, if you're dealing with the crypto, your lending position, your trading, just anything that happens on the blockchain, that gets to end user via indexing. It's simply, tracing what's happening on chain and present to user in a way that they understand. And then there are different indexing methodologies. Some of them give you large amount of historical data, generating a snapshot. Some of them are really need to stay on top, like within 1 second, especially you're doing trading. So those are theoretically different architecture, but they're all called, indexing. So indexing is just getting data off the blockchain.
And then if that data layer is wrong, right?
Yes.
What downstream is going to break?
So from our real experience with the clients, people may have wrong money, like wrong amount distributed if they staked or they participate in some on-chain, airdrop. Some trades can disappear. They try to place a trade and that doesn't show up, and then essentially you miss that window of opportunity. So real money is at stake, essentially. Yeah.
So people can lose a lot of money.
Yes, absolutely.
This isn't theoretical. This isn't maybe someday. We're talking real money based on data that might or might not be right.
It doesn't show up because one transaction or one block is misindexed. That trade will not really go through.
So you're saying everything is based on their interpretation of the data.
It's not based on the interpretation. So think about this way, right? Indexing is what data taken from blockchain. Blockchain is distributed ledger of truth, right? So indexing is this short way. Hey, I'm a trusted provider. I get that data back to user. This is the app that displays to user. The user takes it and believes it, and then you make some decision in trading, right? Based on that data, you submit a transaction back to the blockchain. Blockchain is accurate, but if that data you got from indexer and you make a decision, but that data is wrong, like the blockchain is not going to accept your transaction. So in that case, you will be losing essentially that opportunity, that trade opportunity. And for cases such as token drop, airdrop, token distribution, that type of thing, user will say, hey, you give me the wrong amount, or I put down this amount. So user would end up disputing with the application. Application have to spend more money and double verify what's that transaction. So all that is additional cost, essentially. I mean, your money is still there on the blockchain. It's just like when it's time sensitive or when the data is wrong, you have to spend more money to validate that. So.
Got it. So I know Bitcoin is supposed to be anti-fragile, right?
Mm-hmm.
And there's been recent concern that DeFi itself is very fragile instead. So how fragile is the system if something upstream, such as data or indexing or anything else, shifts? How fragile is DeFi, and how sustainable is that?
I think it's less fragile than the Strait of Hormuz right now, because that can be, for whatever geopolitical issue, that can be interrupted. So I'm bringing this example up. It's actually, in a way, it's similar to blockchain, right? So yeah, again, blockchain is decentralized. All your money is safe on blockchain, but there is a bunch of chains or supply chain, right, to get to the final application to work. Any of that supply chain can break. The good thing is there have been, a few like, major providers in any of those, supply chain. So, but any of them can break. So you can say, if you ask me the honest opinion, it's as fragile or as accurate, as resilient as any of those supply chain vendors or infrastructure providers are. Hence, that's why for degens, people just you know blindly trust or they think this will not happen to them. But as blockchain or crypto gets into more institution, there's going to be more audit requirements. There's going to be more oversights. Yeah. So no, just kind of to secure that, supply chain infrastructure, supply chain risk to make sure that doesn't happen. But as with all financial systems, right? Global financial crisis, even bankers on Wall Street, due to greed or whatever, they can create a systematic risk. That similar risk absolutely exists in DeFi. I mean, this is just the nature of a global financial system. But the good thing is, it's not closed; it's open, right? For better or for worse. Better is North Korea. Better is like some security researcher can submit, a security proposal. Worse is, North Korean hackers coming will also attack. So it's a free for all play field. Yeah.
Yeah. You just said institutional risk, and I used to work in corporate America, and I have no trust as the institutions are providing you accurate information. So so you're trusting the blockchain that's provided information by institutions. How do you ensure the institutions are giving you the accurate data, or are they lying to you? You know,
Yeah, well, I mean, this is unfortunately is the existing state because there have been projects, right, such as the Graph, trying to, set up a decentralized way of getting data off the blockchain with different decentralized way to verify that. And there are many projects that are out there. But the so far the economics of that have shown it's not really very sustainable to operate that. So eventually you more or less settle down into a scenario like, hey, who are the four big cloud providers? Google, Amazon, Microsoft, right? Those three cloud providers. So that's very much is what's happening in the blockchain infrastructure space. But obviously, if you want to go truly decentralized without 100%, vendor risk uh, or kind of tied to any registered institution, you can do that, right? But it's similar to how you know you can call the dark web or the internet that's not really being indexed. It's just going to have a very niche use case. But for blockchain to be adopted by billions of people, there has to be more like institutional scale. And what has shown work is really just a centralized provider auditing data out of the blockchain. The record of truth, obviously, that blockchain itself is decentralized.
so let's talk about the record of truth, because we're now taking that record of truth and we're layering AI agents on top of it, right? And these agents are consuming the data, and a lot of time the AI is not an accurate representation of the world. So, what do you think could go wrong? And are we headed toward like automated decisions based on flawed signals?
Uh, this is a very good question. And the short version to this is it's a work in progress. So at Ormi, at our next, what's coming next is actually we're building like a end-to-end AI infrastructure just for blockchain data needs. So in this kind of from our actual work, we've seen, having AI generating smart contracts, that's probably a bad idea because, a lot of attack surfaces, right? Even people's vibe coded apps get hacked. AI can be good at finding exploits. On the data retrieval side, on the core data infrastructure, getting data out accurately, that you might still want to have a human to double check or AI to validate. But what AI really is good at is once we have this pipeline built out, right? So far, you know, getting and people understanding what's actually going on blockchain is difficult is because it's very much machine language. So what AI is really good is like it takes all that raw transaction, generate various reports, reports that would have normally taken, cost $100,000 just to have one report. AI can generate that in 10 seconds. It gives you an instant snapshot of what's going on the blockchain. But if you really need to go back and validate, sure, you can't spend a resource on that. So that's what AI is really good at: generating data, producing, the final product, and yeah, and eventually AI will be consuming that report and making decision. And then there's a transactional process, which AI right now is not really good at because that needs to be very fast and that needs to be accurate because trade decisions in milliseconds, in sub-second depends on that you cannot wait for it to go to AI because AI can actually screw it up. That you have to really have a very clean pipeline or very clean circuit that goes to the end trade application, because that's actually tied to real-time financial decisions.
So are the agents actually then, since they're not good at transaction, are they amplifying the truth or are they amplifying noise?
So right now, I would not trust an agent to do trades. I mean, they might be good at doing macro back testing or analytics or the patterns, right? But the actual placement of the trade, I think most serious products there are, it's actually the traditional software engineering way. So in a way, right, AI is very good at giving you the macro trend, but the micro transaction, I think it might still be good for a human to do that. But that is changing because there's more and more toolings for AIs to validate the transaction truth. So hopefully later in the future, AI can be 99.9% correct, and it's much better than like say 2 years ago.
So you're thinking that are we creating systems that act faster than we can verify right now?
We're definitely creating a system that's producing more data, actual real data, not convoluted or made up data than what we can consume. Uh, and then on the transaction side, theoretically, yes, because an agent, of course, can place more trades, right? It's automated than a human ever will. But from my limited understanding is it's on such a critical path. The real adoption that's still waiting for AI agent to be a lot more accurate because you're handling real money. If there is a mistake, right, who's going to be responsible for that? But for post-mortem analysis or pre-trade analysis, AI is very good at giving that report. AI could be flagging, hey, now this pattern happened in the market, you know, do a trade or something. Yeah, those are rest of that is just software problem. Yeah. For the low latency stuff, probably AI is not the best right now, but AI can alert, hey, you need to place this trade right now. Yeah.
You mentioned Lazarus Group, and that's just one of the many hackers that attack systems, right? If
Right.
you could name one data level attack vector, not necessarily a hack, but like attack
A
vector, it could be
potential
any.
that, yeah.
Yeah, what would that be?
Um, so the biggest risk, right, I'm seeing is very similar to what happened with the layer zero hack, right? Because in a way there are data providers out there, RPC providers out there, but they themselves are in a way like the where they host their servers, how they manage security is actually much less rigorous than the traditional, enterprise or blockchain, right? And that's just at the very fundamental, like, hey, all the blockchain data source come from say five, six, okay, maybe there are 10 provider out there. Um, Yeah, so the same thing could actually happen again, right? For different dApps out there. So that's a very critical risk, and the rest is mostly just application level. How they decide to treat the data they return. Do they have secondary, security or validation normalization of the data that they retrieve? Those are more questions that's up to those individual applications. So that's why DeFi has risk, right? You can trust the top two or three protocols. The ones that are less rigorous, who knows? Maybe they're too small. That's why they have already been targeted. Um, yeah, but hopefully with all these attacks, right, standardization will form. People will get smarter. Hackers are getting smarter, but providers are also getting smarter. Yeah, just similar to now, you barely see any Windows virus, anymore than like 20 years ago, right? So it's a similar cat and mouse game essentially.
I don't I like the word you used. I don't like it as a word when it comes to technology and money. And you used hope. So hopefully, you
Yeah,
know, what actually, that major attack vector that you said, nobody's talking about it, right? But it's actually real. You just shared it with me. Why is nobody talking about that potential failure mode and what doesn't that worry you?
because I think it's the first time it happened. Really think it's the first time it happened. Maybe it will happen a second time, but I think the second time it happens, people will be more aware of that, and that problem is actually a fixable problem. Because in the application level, as long as they add an extra layer of verification, things like that probably will be patched, will not happen again. So that's why I see, like similar as you're writing software, there is a bug you may not realize, but user uses it and then they discover that and that gets patched. But the problem here is, there is real money here. It's just an evolutionary process. So I don't see it as a long-term systematic risk. Yeah, but short term it may cause a couple more hacks, but I think that eventually can be patched up. So going back to crypto data, right, kind of the major theme is like that's what's so difficult about crypto data. Like data is there, right? Real truth is there, but it's just so much blockchain, so much data on the blockchain to take out the actual piece you need and validate it. Uh, that's a lot of work. And the hack like that happened is because people just didn't see the need earlier to spend more money, make it more robust, to double down on that data integrity, side of things. Um, yeah, so that's what happened. Just the fact that infrastructure around blockchain data is very expensive. It's very difficult to build.
So coming back, going to your project to Ormi, right? How are you improving this landscape? And what's the hardest constraint you've had to build so far while or to face so far while building?
Okay, so the funny thing was, talking about back to the Aave hack, right? The reason we kind of foresaw that happening is because during our time working with our clients, we actually encountered a very similar issue. We do realize, hey, the source data, right, from RPC can be wrong. So we build a redundancy layer to validate, to check, to make sure data passed down to client are correct. And as a background, we power some of the top exchanges that trades, billions of dollars per day, and essentially every 10 seconds we go down or we slip, hundreds of thousands of dollars are at risk. So we have that guarantee we need to make to our clients to make sure um, the data has to go through. So part of that is iteration process over the years. Like the shorter version of two things: we need to make sure data is fast and data is accurate, and we need to turn that into you know digestible data to the end application. Meanwhile, make sure it's fast and accurate.
So it's iterative. So which means that you constantly improve it with every iteration. Where were you wrong? And you now predicted Aave, you must have been wrong early on. And when you were wrong early on, how did you face that problem? What did you think the problem was, and how did that early, not being right on, help you to shape and build your iterative process for the future and get it right more?
So, like for example, in the beginning, like if going a little bit more like technical, right? The what's called the raw blockchain node providers or RPC providers, right? There are big names out there. Some of them are even, valued in the tens of billions of dollars. So you would trust, hey, because they're big, they would give you the accurate data. And we kind of initially made the mistake of relying on a single provider, and we passed the wrong data to the end user. And then they kind of give us feedback, hey, this is the financial loss we experienced because of we trace all the way downstream, hey, who's the provider that's there. So that's what I mean by like, hey, we realize this is a problem. We realize we checked all the existing providers in the industry that does the initial, that runs the blockchain node, right? None of them have actually accurate data. So you do need to, do another level of consensus, filter normalization, and that's kind of part of the iteration process that I was talking about. We because we deal with such large, number of transactions and a lot of real money at stake, so we are able to, you can say, like adapt, evolve, building a very stable infrastructure in this way. But many smaller like dApps, right, who would be our clients, who have not come to us yet, they probably will have a very much similar issue, those people who are trying to do it in-house. But it's just because the scale on their side is not big enough, that problem really hasn't really been like forefront on their mind. Okay, yeah, some data may be missing, but I don't know, it's like $3,000, so people wouldn't care. But it's a whole different scale when one of your clients trade billions per day, right? That's a whole different scale. So
What I just heard you say is that you relied on one provider, they were wrong, and it had a massive cost all the way down the stream.
correct. Yeah. Yes, exactly. Absolutely. Yeah.
And a better method is a better approach is to take data from several providers so you can make sure there's no outlier.
Correct. Yeah, that's the most foundational basis, right? So you're talking about like, hey, the first step of getting data out of the blockchain is you need to run a node, right? Blockchain node, or use a provider. And the funny thing is, when you run your own node, it's even worse data quality because of all kinds of issues that can happen. And then the other thing is, okay, once you have all the data, right, in your own indexer or in your own database, you need to, the next stage, when you're transforming that data, you need to make sure nothing goes wrong either. So that's more like a separate layer, the next layer. Yeah. So you were asking me what indexing earlier is. Like in a traditional term, they call it ETL, like extract, transform, load. So raw data into finished product, finished data. So yeah, very
Excellent.
critical piece of infrastructure. Yeah.
Excellent. So most people think crypto's biggest risk is volatility. It's not. What you're describing is something much deeper, and that's uncertainty in the data itself.
Correct. Yeah.
Victor, I appreciate you going there with me today. Thank you very much for your time.
Thank you for your time.